finally, as step 3 in the solution to our differential equation, let's go develop the total solution. So the total solution, v of t, will be the sum of the particular solution and the homogeneous solution. Okay, add up the particular and homogeneous solutions, and that will give me the total solution. So do you recall what the particular solution that we had obtained was? Well, it was vi. So let me write that down. And the homogeneous solution that we just obtained was a1 e raised to j omega naught t plus a2 e raised to minus j omega naught t. Can you recall what omega naught was? Remember, you took 30 seconds to memorize it. It was 1 by square root of LC. Okay, so that was omega naught. All right, as our final path here in the final few steps, our total solution is given by Vt equals Vi plus A1 da, 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 plus A2 da, da, da. Okay, we're almost there. Let's go ahead and find the unknowns from initial conditions. Okay, recall we were using the ZSR, the zero state response, and so our two state variables were the voltage and the current. And we were given that V of 0 was 0 and I of 0 was also 0. Okay, very, very simple situation. So what I'm going to ask you to do is we give you a little exercise following this little video snippet, and I'd like you to go and do it. Okay, it's pretty straightforward. I would like you to go ahead and find the unknowns from the initial conditions. Okay, what are the unknowns here? Okay, let me give you a few hints. There are two unknowns. There's A1 is an unknown, A1 is an unknown, and A2 is an unknown. Because I have two unknowns. Omega naught was given by this, so it is not really an unknown. Vi is the value that my input voltage steps to at time t equals 0, so that is not a unknown either. So the way I would solve it, there's a couple of hints. So you're given V of 0 equals 0, so you can simply substitute that directly here, and you can, for t equals 0, so this is for t equals 0, so you can say for t equals 0, V of t is 0, so you get one equation. Now the other equation is I of 0 equals 0. What do I do about that? My equation is V of t, but my initial condition, the second initial condition, is I of 0. So how do I relate V and I? Okay, if you like, you can hit the pause button here and think about it for yourself before I give you a hint here. Okay, the hint here is that in the circuit that we have, V and I are related. Okay, recall the circuit that we are working with. So this is Vi, there's an inductor, there's a capacitor, L and C, and my current is I, and my capacitor voltage, is V. This is my ground node. So this node has voltage Vi, and this node has voltage V. So how are V and I related? Well, the hint for you is the following. Notice that I of t equals C dV dt. So there's your hint. So I of 0 being 0, so I of 0 equals 0 implies that C dV dt at t equals 0 is 0. Okay, so there's a clue. So using that little trick there, you should be able to go and figure out the two unknowns A1 and A2. So why don't you go ahead and try it out in the next exercise.